Today we'll be talking about the photoelectric effect. So first off, when we're talking about the photoelectric effect, we're talking about the photon theory of light. Also known as viewing light in terms of a particle, which we call a photon. Now, each photon is going to have an energy of h times f, where h is Planck's constant. And f is just going to be the frequency of the light. Now, since we also know that the speed of light, c, is going to equal to the frequency times the wavelength, lambda, we can also replace our frequency with lambda with the relationship that f is equal to c over lambda. So we find that E can also be equal to Planck's constant times c divided by the wavelength lambda. So this is the amount of energy that a given amount of light, given frequency or wavelength of light, is going to have. Now, how does that relate to the photoelectric effect? Well, what happens is, let's say we have a metal surface. And our metal surface has a bunch of electrons. It's so-called sieve electrons that are moving around in the metal. Now what happens if we have a light source, let's say a flashlight or something, and it shines light onto our metal? What we find that's very interesting is that we actually get electrons coming out of the metal. And as a result, we have to know then that there must be something, that the light must be doing something in order to move these electrons away from the metal. So these are the photons or particles of light. Now, that was the effect that was noticed. However, it was thought that the more photons you have, the more electrons you're going to get out of it. And that was true, but only if you pass something called the threshold frequency. The threshold frequency of light. Namely, there was some specific minimum energy that each photon had to have in order to knock off an electron from the metal. And if the energy was first greater than, then that would mean that the electron would have some amount of kinetic energy that was equal to the energy put in, namely the original energy of the photon minus the work function, or in other words, the minimum amount of energy in order to knock off that electron. So the more energy we put in that is above the minimum, that is above the work function, the higher the kinetic energy will be. Now what happens when the energy of the photon is going to be less than the minimum required amount of energy? Well, then we find that nothing happens, which is to say that no electrons are being moved off. So this was the photoelectric effect of shining a light upon pieces of metal and then suddenly finding that based upon different frequencies, we could have electrons being knocked off of the metal.